Hi, this is Ms. Nickel. This recording is about using the Phet Wave on a String simulation to find wave length and wave speed at different frequencies. So you can just put Phet, spelled P-H-E-T, wave on a string into your browser, Google or whatever, and search, and it will take you to the simulation screen that looks like this. You click on the play button, and this is what you see on the opening screen. So the settings that you're going to want to select oscillate in the upper left-hand corner and no end in the upper right-hand corner. Then press pause so that the string just kind of stops waving for a minute. Hit restart to make it flatten out. Now you're going to go to the bottom of the screen. You want to take amplitude up to 1.25. Frequency at 1.5 is fine for now. Damping to 0. And tension, when you collect your data for the finding patterns and waves that encode information investigation, you can choose any tension you want. I think the tension I gave was high, but if you would like to use low or medium tension, that's fine, but just keep it the same throughout. So I'm going to put it on medium tension, and I'm going to select rulers, timer, and reference line. All those little check boxes on the lower right-hand side. Anytime I want to completely change or go back to the home screen, basically, I just hit the orange circle in the lower right-hand corner. All right, so my goal then is to look at the effective frequency on wavelength and wave speed. So for the rest of the experiment, the only thing I will change is the frequency. And I'm going to start out with this frequency of 1.5 hertz. So I'm going to measure wavelength first. And I'm going to take this reference line. You can see the red reference line. I just pull it down so it lines up with a string of beads. And that's going to help me figure out where the resting position is, and that way I can tell when I completed one wave cycle. All right, so I want to make sure my ruler is lined up so that the 0 centimeters is even with that green bead that's right on top of the piston, and that's how I'm going to measure the wavelength. And I'm going to click on slow motion because it makes it a lot easier to stop it when it's gone through one cycle or 1 second. All right, so for wavelength then, I'll press the play button, and my goal is to have one complete wave cycle occur before I pause. All right, so here I go. Up and down, pause. Now I'm a little bit shy of one complete wave cycle, so I can hit the little inch forward button, I call it. So here we go, click, click, and now I have one complete wave cycle. And you can see the green bead is on the line in 3 places, at the start of the wave, at the middle of the wave, and at the end of the wave. So I'm going to try taking a screenshot now. It may interfere with the recording, and then I'll just splice them together. So here we go. All right. So looks like we are still recording. All right. So I'm going to draw on this and show you where that wave cycle is then. So like I said, we've got the beginning of the wave cycle here. Then we have a complete down. That's the amplitude in the downward direction. Here's the middle of the wave cycle there where I put the X. And we have a complete up. And the end of the wave cycle is right here. So it looks like it's, if we say that each of the little marks is 0.2, we've got 2 centimeters here, then 2.2, 2.4, and I'm going to call this 2.5 centimeters. So wave length, which is lambda, equals 2.5 centimeters. And that's what you would enter into your data table for a frequency of 1.5 hertz. Okay, but we still need to get wave speed. We've only done wavelength. So we're going to get rid of the screenshot here and go back into the simulation, hit restart, and we are going to measure our wave speed. So to measure the wave speed then, this time I want the timer to be the focus. And I press the little play button on the timer, but because the simulation isn't running, it doesn't actually start. You just see the black square, and that's telling us that as soon as we start the simulation, the timer will begin running. So I'm going to play the simulation this time for exactly 1 second, and then I'll tell you how you're going to figure out wave speed. And here we go. It starts, and we're going for 1 second. Whoops, that was really too soon. All right, now I'm going to inch it forward a little bit. There. All right, so we've got exactly 1 second. And this time what I care about is how far has the entire disturbance traveled. So where does the string of beads become flat, all right, relative to the start position? So here, I'm lining up the ruler, so I'm going to screenshot it, and then we'll measure it off and find out what wave speed is. So, there we go. All right, so we're going to say that our start position is the same as it was before when we did wavelength, but this time we want to know how far the disturbance has traveled in 1 second, right? Remember, we are interested in distance over time for wave speed. So our stop position this time is going to be, it looks like right here. It doesn't have to be on the green bead. And you can see that that is going to be at about, here is 3. So then we go 3.2, 3.4, 3.6. Looks like, I'm going to say 3.8 here. So we're going to say wave speed is equal to 3.8 centimeters, and that is per second. And the reason it's per second, remember, we've got our clock down there, and we timed it. That's how far it moved in exactly 1 second. And remember, this is also our wave speed at a frequency of 1.5 hertz. So now we measured our wavelength and our wave speed at 1.5 hertz. At this point, you would be ready to go to a different frequency. You could hit restart again, choose another frequency. I'll show you here. So restart would flatten it out again. You could choose another frequency just by moving your slider. Maybe I would take it up to 2 now. Doesn't have to be exact, but so I'm going to take it up to 2 hertz, and I would repeat the same process again. If I want to reset the timer, I hit the backward arrow, but first I'll be figuring out wave length. So to measure wavelength, remember, I want to do 1 complete wave cycle. And after I get that, I'm going to do wave speed, which is when I time it for 1 second and see how far it's moved. And I record both of those pieces of data for 2 hertz, and then you repeat that. I think we had a total of 5 measurements for 3 more times after that. All right, so I hope that helped you understand how to use the wave on a string simulation to measure wavelength and wave speed, and also that you can use this to fill out your data table for the finding patterns and waves investigation. See you in class. Bye.